Yeah, tell me. Hmm. Saturation का मतलब क्या होता है? नहीं, 100. How do you define saturation? Excuse me. Hello. अब छोड़ दो तुम लोग, बाद में बात करो, ठीक है? How do you define saturation? नहीं तो कौन से बता रहे? How do you define saturation? How do you define saturation?
The temperature at which the moisture holding capacity is 100%.
That is dew point. What is saturation?
Saturation means maximum holding capacity of a air and maximum test particles.
What is saturation?
Maximum holding capacity.
अच्छा, मतलब और कॉम्प्लिकेट कर दोगे तुम इसको? नहीं. Saturation is defined as when the relative humidity reaches 100%. That's it. Air is said to be saturated when the relative humidity of that air column is 100%. ये समझ में नहीं आया था तो क्यों नहीं बोल रहे? What is saturation? How will you define saturation? The saturation is when the relative humidity reaches 100%. So if you would have understood that, there is no question that whether it is a relative humidity, a specific humidity, or absolute humidity. हमने बताया था ना कि when the air column rises, it cools adiabatically, right? When it cools adiabatically, so obviously its relative humidity will increase because of decrease in temperature. And when it reaches 100%, it is called saturated. So do we need to define that as specific way? Relativity, when the air has 100% relative humidity, that means, that is the consequence, that it cannot pick up any moisture if it is on the ground, even if the source is there. That means its holding capacity is almost equal to that of its actual content, right? और क्या है? बहुत सारे क्वेश्चन में समझ ली. ठीक है. अब अर्थ इज स्फीयर तो कोल वाल फ्लैट क्यों है? अर्थ तो गोल है ना, कोल वाल फ्लैट क्यों है? When the sphere, the circle is smaller, you can feel the curve. When the circle is smaller, let it start increasing. The circle starts increasing. Look at छोटे से बोर्ड पे ये फ्लैट सरफेस बहुत दूर तक जनरेट, right? For all practical purposes, regional wise, Earth is treated as a flat surface. गंगा प्लेन क्या है? पूरा फ्लैट सरफेस. When Earth is curved like this, the Ganga plane should be like this, because this circle is so big that for 100 kilometer, 200 kilometer, 500 kilometer, because the angle of that curve is very, very small. So unless until you count, say, let's say India and US, you may not be able to feel that curve. Within India, you may not feel curve. Number one. Number two, when we are seeing that east coast and west coast, offshore and onshore, it's a relative term. When we are talking about equator, right? Now, equatorial area will be a flat surface like roll. Getting that? So then, when the air is converging in this direction, in the northern hemisphere, the trade wind direction will be like this. In the southern hemisphere, the trade wind direction will be like this, turning leftward. What do you mean by onshore? The wind which is coming towards the shore, from the ocean towards the continent, right? So obviously these winds are coming from the ocean and these on the continent, onshore. These winds are moving away from the continents and towards the ocean, offshore. That means shore se off. वो क्लियर नहीं, वो मुझे क्लियर नहीं. लेट्स ट्राई टुगेदर. हाँ, ठीक है. Hope you understand adiabatic lapse rate. Adiabatic, what is adiabatic? नहीं हो रहा, वॉल्यूम चेंज, वॉल्यूम चेंज, हीट जहां पे एक्सचेंज हो रहा है दैट इज डायबिटिक. When the heat is not involved, yet there is a change in temperature, we call it adiabatic, right? Now we are confused about dry adiabatic and wet adiabatic, right? When we say adiabatic, that means when the air rises, it expands like this, right? Same area of air will occupy larger area. So cooling is because of expansion, or cooling is because of change in volume, or cooling is because of increase in volume, right? Now let's take dry air and wet air. The expansion in dry air will be more or wet air will be more. As simple as that. So the dry air will expand more, so volume is more, so its temperature decrease rate will be higher. When the wet air is there, its expansion will be relatively lesser. Consequently, the wet adiabatic change will be less as compared to dry adiabatic change. Should I try it again? Right? सिंपल सी चीज है, जब भीगा कपड़ा, गीला कपड़ा है और ड्राई कपड़ा है, इसको यूं करो, फैलाओ तो गीला कपड़ा थोड़ा मुश्किल से फैलेगा, right? Because it is slightly heavier. So when we say wet air, it is wet means गीला हो गया, like saturated soil. When we say saturated soil, that means soil moisture balance is perfectly maintained with respect to its holding capacity. When we say cloth is wet, what do you mean by wet? Completely wet होता है, actual literal sense में वो तभी होगा जब वो पूरी तरह से गीले हो गए, half wet, semi wet, right? So when the cloth is wet, you try to spread it. When the cloth is dry, you try to spread it, which will spread faster. Dry, right? So when it is spreading, the cooling here is because of spreading, increase in volume. So when the increase in volume is faster, the temperature decrease will be faster, right? When the cooling spreading rate is lesser, then the temperature decrease rate will be lesser. As simple as that. And you can remember it also that way, that wet adiabatic lapse rate will be smaller as compared to dry. Wet adiabatic lapse rate is fixed, 5 degrees Celsius per kilometer. Dry adiabatic lapse rate is not fixed. Nobody asked this question yesterday. The dry adiabatic lapse rate is 5 degrees Celsius to 10 degrees Celsius. Why? Because when we say dry air, it means 99% humidity and maybe 1% humidity. So with the variation in humidity, the rate will vary. Actual dry air may experience decrease of temperature by 10 degrees Celsius per kilometer. But the moment it is 99% humidity, its rate of decrease will be exactly near to 5 degrees Celsius because it is almost a wet, right? So that's why dry adiabatic lapse rate varies. It is not having a fixed rate, unlike environmental lapse rate, unlike dew point lapse rate. Hope it's clear. Next. Yeah, come. Mm-hmm. Mm-hmm. Dew point is very high. Huh? Okay. What is the specific humidity? Weight of air versus weight of moisture, and it must be close to the ground. The statement, if you want to establish a relation, it should be close to the ground. It will help you understand, because specific humidity remains same. Even if you go higher up, it remains same because weight of air is not going to change. So whatever weight of air is on the ground and it contains certain moisture, let's say weight of air is X and the content of moisture is Y. There is a ratio. So when you take volume is increasing at a height of, let's say, 2 kilometers. So again, the weight of air will remain the same, though it has expanded. But when we talk about weight, that remains 2 kg. Whatever weight of moisture on the ground, the same is there, right? When we talk in terms of volume, since volume has increased, so there is a decrease per unit volume of moisture, but per unit weight, there is no change, right? So whatever a specific humidity is on the ground, that remains in the upper air as well. Now come to the relationship of when dew point is high. When the dew point is high, means cloud is formed closer to the ground, means moisture content in the air must be higher. The specific humidity indicates moisture content in the air with respect to weight of the air. Nice. Hmm. Hmm. No, when we're talking about the specific humidity, volume doesn't count. When we let's take it back. Dew point temperature is high, right? That means cloud has been formed at a closer uh, height. Closer height cloud formation indicates that means saturation is attained at a much lower height. How saturation can be attained at a much lower height when the moisture content is very high? When we talk about moisture content on the ground very high, it is a specific humidity. Clear ना? और कुछ पूछना है? बोले तो बहुत सारे क्वेश्चन है, तो 3 ही मिले मुझे. हम्म. ये भी पूछा. Maximum holding capacity of air. First we understand what is maximum holding capacity of air. Let's take बालू का एक ढेर लेते हैं, तो ठीक है. बालू का एक ढेर छोटा सा ले ले, टीला. उसमें पानी की बूंद डालते रहो. Let's try to put each drop of water into the eaves of sand, right? After a point of time, if you put one drop, that will come out of the eaves. There is a possibility. So that is the maximum holding capacity of that heave, of that sand. Got it? Now, if you try to heat up the sand from below, let's say it is put on a tawa and you are heating the tawa from below, its holding capacity will increase or decrease? Because it is warmer now. Increase, right? If you somehow cool down that soil, sand particles, its holding capacity will decrease, right? So moisture holding, exactly similar happens in the case of air, right? The moisture holding capacity of air will be higher when its temperature is more. Its holding capacity will be lower when its temperature is less. Is clear? Now, how moisture holding capacity and relative humidity is related? Like relative humidity is what? Actual amount of moisture. It's a basically a ratio. Ratio between what? Actual amount of moisture present in the air with respect to its moisture holding capacity, right? So once the air rises from the surface, the actual amount of moisture will remain constant. So what will be the term which we quantify the relative humidity? The term will be moisture holding capacity, because one component is constant. So relative humidity will be determined as per the moisture holding capacity of air, right? So relative humidity will be inversely proportional to moisture holding capacity. If the moisture holding capacity of air is more, relative humidity will be less. If the moisture holding capacity is less, then relative humidity will be more. Now, moisture holding capacity is determined by temperature. So, directly we can correlate relative humidity with temperature, right? So, relative humidity and temperature will be inversely proportional. If the temperature is increased, relative humidity will be decreased. If temperature is decreased, relative humidity will be increased. So the chances of saturation will be higher when the temperature is decreasing. Getting that one? Mm-hmm. स्नोफॉल जनरली नहीं होता. आइस पेलेट्स हो, आइस बॉल्स हो. देखा नहीं कभी? सर पे खाया कभी? है? मेरे बाल उसी वजह से उड़े हैं मैं. तो हेल स्टॉर्म को हम मिक्स्ड फॉल कहते हैं. इट्स बेसिकली बिकॉज रेन ड्रॉप्स प्लस आइस पेलेट्स टुगेदर. दैट्स व्हाई वी कॉल इट हेल स्टॉर्म, right? Because snowfall will not come along with the raindrops. snowflakes. It is moving falling in the form of flakes, small, very thin flakes, right? Cake-like, very small. So that is snowfall. Raindrops, rainfall. When we say mixed fall, raindrops plus ice pellets, ice balls. Clear? Even when we in boom in Africa, it's non non-directional. Not non-directional. A local area. Like so very often, if you see the wind will blow from west to east in northern plain. Right. Generally, it will blow west to east. But sometimes in the local region, it can blow east to west. Local winds are produced because of local conditions. Like, for example, in the northern plain, imagine in the month of April and May, right? The temperature is very high. So, if the wind is blowing from east to west, so it may be connected with Bay of Bengal wind, right? So, when the Bay of Bengal wind is coming, so it will bring some moisture. So, it will distort the formation of loop because the moisture content in the air will decrease the temperature of air, right? When it is moving from west to east, actually it will remain warmer. So if you look at the summer months, if westerlies is blowing, westerlies means in Indian context, local wind. Westerlies means west to east direction, not the typical traditional westerlies. So that will be much, much warm. So blue will be very, very strong when it is west to east. It will be very weak if it is east to west. Then specific direction. Local winds का तो यही है ना कि that depends upon the local conditions. And just suppose this is a rocky area, that one is sandy area. So rocks will be heated at a much faster rate as compared to sandy area. So they will move from sandy to rocky area. Now this side you have rocky area, that side sand, this side also sand. So there will be local convergence also. That's how the dust devils are formed. Right. So the local winds may not have a specific direction, but some of the local winds do have direction. Like for example, Sirocco, which moves from Sahara Valley to Italy. So that is a much longer regional local wind. Right. It's not confined to a particular smaller area. So the moment it is bigger, for example, monsoon. Monsoon is not permanent wind, it's periodic wind. But the scale of monsoon is so huge that it covers the South Indian Ocean, North Indian Ocean, up till Himalaya. So it is no more a local wind. Are the monsoon winds are due to the shift in वो हम लोग बात कर लें वो जब मानसून पड़ेंगे दैट्स देयर बट देयर आर सो मेनी फैक्टर्स जब इंडिया की बात आती है तो हम लोग वैसे ही थोड़ी कॉम्प्लेक्स है इवन द नेचर हैज मेड अस वेरी कॉम्प्लेक्स व्हेन आई से इंडिया इट इज अबाउट इंडियन सबकॉन्टिनेंट वी इंक्लूड बांग्लादेश पाकिस्तान श्रीलंका नेपाल ऑल दीज कंट्रीज आर फुल ऑफ कॉम्प्लेक्सिटीज अभी हमने क्या पढ़ा इन द ट्रॉपिकल एरियाज the trade wind is onshore along the eastern coast and offshore along the western coast. All over the world it will be true, but it fails in India. The only country in the world which receives both eastern coast and western coast receives onshore wind in one go in one season. There is no other country in the world. Uniqueness of climate in India. Right? तो नेचर ही हमें बनाया वैसा Africa के eastern coast that means Indian coast. So now you have to take into account equator. Equator area it is passing through middle of Africa. Now if you look at South Africa, so that is again very close to Tropic of Capricorn. If you know tropical, the tropical region that is tropical region 30 degree to 30 degrees roughly tropical region. We have already talked about shifting of pressure belts, right? So that will be 25 to 35. So even if in this winter season, the subtropical high pressure belt is around 25-degree latitude, so its coverages are roughly around 35-degree latitude. So the beginning of the westerlies is the poleward margin of subtropical high pressure belt, right? So look at subtropical high pressure belt that will start 35-degree, right? At 35-degree or 30-degree. So the westerlies belt are beyond 30-degree latitude. And South Africa roughly whole will be covered around 30-degree latitude. So this will be affected by trade. Same trade wind. Eastern coast or western coast, I'm talking about the region. It will be covered by trade. South of that, you can expect westerly, like South America. I hope you remember. South America is much elongated, right? So if you look at Chile, again uniquely placed in such a way that northern portion of Chile experience uh, trade wind, central portion experience the subtropical high pressure belt, and southern portion experience westerlies. Right. So Chile has variety of climate because it is latitudinally far spread over a much longer latitude. Southern tip of South America experiences westerlies. When you see rainfall distribution, you must have seen that the western coast of South America in the south tip will be receiving very high, just below Atacama Desert. So Atacama Desert is a zone of uh, Atacama Desert is a zone of offshore winds, right? So now look at here, right there you have trade wind. Just below that you have westerlies, right? So you have whenever you see a coastal desert, the only thing you are offshore winds. That's it. If it is a desert, means it must be along the offshore. That's it. Blindly conclude. Now, which offshore? According to latitude, you can easily identify. बढ़े आगे. Periodic wind. What is a periodic wind? Which changes its direction. Changes its direction with time. That means there is a temporal change in the direction of the wind. That means there is a periodical change. When we say periodic, it is basically related to time, right? Now, there are two components, direction and time, right? Time may be daily, there is a daily change, or there is a seasonal change. The one which changes its direction daily are two recognized ones, the land and sea breeze and the mountain and valley breeze. The seasonal, the most well known is monsoon. The most well known is monsoon. This way, when you define monsoon, we can start with monsoon as a periodic wind. Monsoon is a seasonal. Monsoon is a wind which experiences reversal of direction. Right? So whenever there is change of direction or reversal of direction, that wind will be put into the categories of periodic. Now, direction is determined by direction. Coriolis force. Very good. What is the primary factor of direction? Pressure gradient. Right? So, direction of the wind is primarily determined by pressure gradient force. Right? And pressure gradient force is determined by, what do you mean by pressure gradient force? A force between the two pressure system, between high and low pressure, right? So that means any area is having high pressure and low pressure and there is a variation into it, right? That's how it will be determined. If you look at as a layman, let's say suppose I'm talking about this region. Same region experiencing reversal of wind, we'll call it periodic wind. Let's say suppose in one particular season, the wind or time, the wind direction is this. What can we conclude with definitively? That this is a high pressure area and this is a low pressure area. Blindly. When we say reversal of wind, means opposite direction. So if in another point of time, if the direction is reversed, that means wind is blowing in this direction. So at that time, that point of time, you can say that this is a high pressure area and this is a low pressure area. Hope we're clear, right? So periodic winds are characterized by reversal of wind, right? It's characterized by reversal of wind or change in the direction of the wind, which is nothing but change in the pressure system, or reversal of किसका इतना अच्छा म्यूजिक बन रहा है बज रहा है अच्छा अच्छा pressure system, reversal of pressure system. Is it clear or not? That means reversal of wind direction is nothing but reversal of pressure system. And the change in pressure is because of fundamentally the Coriolis force is also responsible, that is at a global scale. But fundamentally at a local and a regional scale, the change in pressure will be definitely associated only with temperature. So we can say that the reversal of pressure system is nothing but the reversal of temperature system. Hope we're clear? Right? Just in the same example, what we are talking about, let's say suppose this two region we are comparing. In one point of time, the direction is this. So we can say that this is high pressure and this is low pressure. So we can definitely say that this is low temperature and this is high temperature. Is that clear? Then the direction is reversing in the same region. So we can definitely say that this is high pressure and this is low pressure. That means this is low temperature and this is high temperature. Right? So periodic winds are nothing but a product of change in temperature regime of that area. Like in our country, what happens? During summer season, the whole of northwestern part of Indian subcontinent, perhaps the only system where we are with Pakistan, and Pakistan is with us, that whole of northwestern India experiences very high temperature. High temperature means low pressure. Low pressure means oceanic areas will have relatively lower temperature. High pressure, so wind will come from both the sides. Winter season, the situation will be exactly reversed. The whole northwestern plain, low temperature means high pressure, so wind will start moving in opposite direction. Reversal of wind. So if you look at that periodic wind, they are nothing but the periodical change in the temperature of the adjacent area that produces change in the pressure system, hence reversal of wind direction. So whenever we look at any periodic wind, you should look into the change in temperature. That's why when we learn monsoon, the first thing we should start with is the temperature regime of the area and how high temperature is transformed into a low temperature area and vice versa. Let's talk about land and sea breeze. What do we mean by breeze? Slow moving wind is called breeze. Why the wind will move slow? That means pressure gradient force is weak. That means when we say pressure gradient force is weak, means the difference in the value of the adjacent pressure is not very high, it's very small, right? That means difference in the temperature is not very high. So can we say that temperature gradient, low temperature gradient will produce breeze? Low temperature gradient will produce low pressure gradient. Low pressure gradient means low PGF. Low PGF means slow moving. High temperature gradient, steep temperature gradient means steep pressure gradient. Very strong PGF means very high velocity, right? Just write it down. Like when we say that gentle temperature gradient will produce gentle pressure gradient, that means low PGF means low velocity of wind means breeze. Exactly opposite case will be there when we are talking about jet stream, right? So whenever there is a scope of steep or high variation in temperature in the adjacent air, we can say that a possibility of high velocity wind. In the upper air, it is called jet stream. On the ground level, it will be storm, right? Land and sea breeze. Land and sea breeze, if you look at here, let's see, suppose the breeze, the oceanic area. Now, during daytime, what will happen? Here, the temperature will be high comparatively, pressure will be low. So, inward movement, rise of air, right? So, the loop during daytime will be created like this. This portion is called sea breeze because it is moving from sea towards land. Night time, temperature here is higher relatively. Pressure is low, right? So obviously, inward moving. So what will happen? The loop will be reversed. Clear, huh? No issue. Now, the impact of this breeze is on the temperature. That is why coastal areas do not experience extremes of temperature. Even in the areas close to the equator, like Mumbai, Trivandrum, Kochi, they do not experience as extreme a temperature as Delhi. Because the moment the temperature starts rising, the cool air from the ocean surface comes and reduces it. During night time, that when the temperature starts falling, again it transfers the heat exchange between the ocean and the continent. That's why continental area, coastal areas. Now, what will be the consequence here? Coastal areas are cooler relatively, and coastal waters are warmer relatively. That's why interior of the continent will be having much higher temperature. Delhi is located at almost around 25-26 degree north latitude, right? And Chennai is located at around 10 degree, 12 degree latitude. But Chennai will not experience more temperature than Delhi during summer season because of that's what you call the climate which is produced because of ocean is called maritime climate. and the interior of the continent is continental climate. Right? When we say continental climate, that means extremes of temperature. That means temperature range is very high. Annual range of temperature and daily range of temperature is very high. When we say maritime climate, annual range of temperature and daily range of temperature both are on the lower side. When we talk about the small oceans, when we say smaller oceans, it's sometimes also referred as marginal seas. The smaller oceans will be warmer as compared to the bigger ocean located on the same latitude. Isn't it?
The smaller oceans
Will be warmer. A smaller ocean will experience higher temperature extremes. That means summer, much higher temperature, winter, relatively much lower temperature. What do you mean by smaller oceans? The portions of ocean which are surrounded by land from many sides, like let's say Caribbean Sea, right? So a good number of islands right there. So the ocean water in and around Caribbean Sea will be warmer because of the effect of the islands. So generally what we get confused into is that we generally consider ocean as a source of impact of temperature on land. We generally forget that land do have its impact over oceans. That will help you understand why the intensity of cyclone is higher, and in fact, the highest intensity cyclone is found in the Caribbean Sea. Why Bay of Bengal? One of the reasons, not all, why Bay of Bengal produces high intensity cyclone, not Arabian Sea. Right? Huh. So if any atmospheric disturbances or atmospheric phenomena which are dependent on temperature, right? So if the temperature is higher because of any reason in a particular area, so that will intensify, right? So here I'm not expecting you to understand cyclone. Forget it. What I'm interested in, just remember these both ways. It's not a one-way phenomenon. That the cooling effect over the continent is because of oceans, definitely during summer season. Similarly, the warming effect of oceans is also there during summer season. So the ocean temperature will be slightly higher as compared to their own latitudinal position if it is closer to the continents. Unless until otherwise it is expected, like cold ocean currents are found as a different issue. The coastal waters will be slightly warmer as compared to their counterpart because of the exchange of heat between land and sea. Right? Now, mountain valley breeze. Again, the same situation, mountain and valley breeze. It's a breeze, right? Mountain breeze means when the air glides down the slope of the mountain from the top towards valley. Valley breeze means valley towards mountain, right? Let's say suppose this is a mountainous area. This is the valley portion. This is the mountainous portion. During daytime, now you guys tell me, it will be mountain breeze or valley breeze. Hmm? Valley breeze. How do we come to know? Okay, good. So that means we can easily correlate with temperature. During daytime, the top of the mountain will be exposed to the sun, and the temperature that will be higher, right? Here the temperature will be slightly lower. So consequently, what will happen? A local level loop will be created Here, this area will be experiencing descending air, and this area will be clear. Exactly opposite case will be during night time. This is called katabatic wind, and black one is called anabatic. These all are local wind. Katabatic wind and anabatic wind may not necessarily be associated with mountains and valley breeze. When under the influence of pressure variation, very slowly, the top of the mountains provides wind towards the bottom, towards the foothills. That is called katabatic. When it is moving upslope, it is called anabatic. Upslope, anabatic; downslope, katabatic. As far as monsoon is concerned, we'll discuss it later when we discuss Indian geography. Because first we have to understand the whole physiographic, the impact of physiographical features over the temperature and then pressure system and all, right? Let's talk about cyclones. Cyclones. What are cyclones? We have a bit of idea about it. Cyclones develop in and around a low pressure system, right? So that means it is a version of low pressure system. Now, for any atmospheric disturbances to be called a cyclone, certain speed of wind is must. Like minimum criteria is the speed of wind must be 33 kilometer per hour. That is the first category cyclone. That's how we have first category cyclone, second category cyclone, and fifth category cyclone. First, second, third, fourth, fifth, and sixth. Fifth. So generally, cyclones are categorized on the basis of the velocity of wind within the cyclone. Right? Generally, it is treated as 50 to 100 kilometer per hour speed, category 1. Though it starts with 33 kilometer itself, but roughly it is treated as 100 to 150 kilometers per hour, category 2. 150 to 200 kilometer per hour, category 3. 200 to 250 kilometer per hour, it is category 4. More than 250 kilometer per hour, category 5 cyclone. And the speed is measured for at least minimum 2 minutes. The speed must be there. This speed must be maintained at least for 2 minutes within the cyclone. So if the speed of the wind is very high, the capacity of destruction will be equally higher, right? So that is directly proportional to that. It is exclusively, this kind of wind speed is expected only in tropical cyclone, not in temperate cyclone. When we talk about cyclones, there are two categories of cyclones. We'll come that to later again. Now, that means a high velocity wind is required. High velocity wind means steep pressure gradient force, right? A steep pressure gradient force means a steep variation in pressure means a steep variation in temperature, right? Now, cyclone is a system. Now, if you look at the low pressure area, it is the first stage of the convergence, right? Where normal wind will be produced 8 to 10 kilometer per hour. When the low pressure intensifies further, that means speed is increasing. It is called depression. When depression is further intensified and the intensity of low pressure is much more intense than depression, it is called vortex, or plural is vortices. When it further intensifies, it is called cyclones. So cyclone is nothing but different stages of low pressure system. Clear? Now, here itself, we can understand the predictability of cyclone, whether cyclone can be predicted or not, especially in terms of tropical cyclone, which is far more destructive than temperate cyclone. So when we're talking about low pressure, we can easily watch it. When the low pressure intensifies to become depression, keep watching, keep an eye on it. When depression is transformed into vortices, take care. Right? When the vortices are intensifying, it may take a week or so. Cyclone is supposedly, especially tropical cyclone, is supposedly the most disastrous atmospheric phenomena faced by humanity. Like, for example, Phylline, last year, Phylline in Orissa and Andhra Pradesh was one of the most disastrous. And if we were not prepared that disaster management wise, the damage could have been far more higher. But because the warning system has improved, the efficiency of technology and all has improved, so we could easily take measures before it actually hit the coastal areas. So you may have question about predictability of how cyclones can be predicted. Cyclones can be predicted by understanding the different stages of low pressure system development, especially in the case of tropical cyclone.
Sir, why cyclones are only generally in the coastal area?
Who told you?
Maximum cyclones would go
Look at here. Why did I ask a question? Because when you think, you should think holistically. When we are talking about cyclones, we are talking about both tropical and temperate. What you are saying is true about tropical cyclone, but totally untrue about temperate cyclone, right? Let's say, suppose it's all the requirements. Why do human do anything? Why does natural phenomena occurs? So if we understand, we can explain the reasons. So cyclones may have certain requirements. If that requirement is not fulfilled over the continent, it will not develop. If the requirements are fulfilled, it will develop.
low pressures generally develop compare areas.
That's true. अभी साइक्लोन पूरा पढ़ लेते हैं, उसके बाद हमको नहीं लगता ये सब बच्चों वाले क्वेश्चन खुद आपके लिए भी रहेंगे. वैसे भी आपका नाम धर्मेंद्र है. Hey, there's nothing like you are going to be asked in interview board also. Be prepared. धर्मेंद्र को एक क्वेश्चन पक्का रहेगा, मैं गारंटी के साथ लेंगे. So at least you can say that expectation from my name is much bigger. So that's why that has always forced me to perform better. Even the teacher used to tease me that you are Dharmendra, so behave like Dharmendra. Huh? No, you should go after Basanti. You are Dharmendra. Not IS. Right. Take it sportingly, huh? Right? So cyclones, Write down, please. Cyclones are atmospheric disturbances. Cyclones are atmospheric disturbances where which involves a close air circulation, around a low pressure center, which involves a close air circulation around a low pressure center, around a low pressure center, and the direction of the wind is anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere. Anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere. The direction is basically associated because of this direction is basically because of the wind blows along a circular isobars. Along a circular isobars. Along a circular isobars. Hence, the Coriolis force and pressure gradient force acts from all directions. Coriolis force and pressure gradient force act from all directions. All directions. Consequently, a circular wind is produced. Which is very often similar to gradient wind. Hope you remember gradient wind. What is the requirement of gradient wind? TGF, CF, and frictional force, both balances. All these three balances each other. That's gradient wind. Paragraph change. On the basis of their latitudinal location, cyclones are tropical cyclones and temperate cyclones. Cyclones are tropical cyclones and temperate cyclones. Tropical cyclones originates only over the ocean surface. Because the ocean surface, because the energy needed for its growth and sustenance is supplied by water vapor. That's why the best breeding grounds are tropical ocean waters. That's why The best breeding grounds are tropical ocean waters. The energy to the temperate cyclone is supplied by the heat exchange between the two contrasting converging air masses, two contrasting converging air masses along the front. Since this convergence can take place, both over the oceans as well as the continents, since this convergence can take place both over the oceans as well as the continents, temperate cyclone can breed anywhere. Paragraph change. The isobars in tropical cyclone are closely spaced with steep pressure gradient and more circular. Whereas the temperate cyclone has more elongated, widely spaced, the wind velocity in tropical cyclone is very high, making it more destructive. Besides, the rainfall in a tropical cyclone is torrential, concentrated, and heavy. Torrential, concentrated, and heavy, making it more destructive through floods and storm surge. Making it more destructive through floods and storm surge. Storm surge, STORMSURGE, storm surge. Storm surge means a very high wave associated with high tide. So the wave becomes much more stronger and penetrates far deeper into the continental areas. Torrential rain means very heavy downpour in a relatively small time. That means cumulonimbus clouds. Right? Snowfall in tropical snowfall is relatively common in snowfall is relatively common in temperate cyclone, but is absent in tropical cyclone. Now, let's look into the fact. Tropical cyclones, since we are surrounded by tropical cyclones, we don't face generally temperate cyclone, at least it's in intense form. Only the part of western disturbances covering portion of Jammu and Kashmir and the northern plain area. During winter season, we have temperate cyclone, a glimpse of temperate cyclone, not the actual temperature. That's why we call it western disturbances. Right? Cyclones are atmospheric disturbances. So let's talk about individually. First, the tropical cyclone. Any question if you have in between here, especially regarding the first paragraph, when you look into the anti-clockwise direction, the normal direction of air or wind in the northern hemisphere is clockwise. Coriolis force towards right, towards right, towards right. So it is clockwise. In the southern hemisphere, it is anti-clockwise, normal wind direction. But in the case of cyclone, the wind direction is exactly opposite. There is no change in Coriolis force, only change in isobar and the structure of pressure gradient or structure of pressure system, which makes it anti-clockwise. What happens? This is a regional phenomenon, global phenomenon. That means isobars are linear. That's what makes trade wind like this, westerlies like this. Though they may not be able to make full circle, but cyclones are relatively circular winds. They are relatively directional winds, making an angle with the isobars. What happens when the isobars are circular in nature, like this? So it will happen just like the way we have discussed gradient wind. So the wind will be coming from this direction, from all directions, right? All directions. Nature. This will be the direction of the pressure gradient force all along, right? Now apply Coriolis force. By the time it reaches here, 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 so ultimately if you join it, the wind will be anti-clockwise direction in the northern hemisphere and clockwise in the southern hemisphere, right? That's the first aspect. Steeper isobars, that means closely spaced isobars, presents or reflects steeper gradient. A steeper gradient means greater force. More intense pressure gradient force means higher velocity of wind. That is the requirement. Now, what happens in the case of tropical cyclone? As we know the term tropical, now hopefully we understand what is cyclone also. Those which originates in the tropical latitude and around is called tropical cyclone. If you look at the requirements or prerequisite for a cyclone to be formed, or the favorable conditions which favor its formation. The first requirement is high surface temperature. That is what books write. That's why I'm also writing it. The temperature of ocean water must be around 27 degrees Celsius or more. Okay? Why it is actually required is look at here, it is relatively a local phenomenon. Relatively, it's not a global phenomenon. It's not like cyclones are covering a much larger area. 150 kilometer, 200 kilometer will be the maximum diameter of a cyclone. Maybe as small as 6 kilometer, 7 kilometer diameter. Right? So, it is a local phenomenon. When we talk about this 27 degrees Celsius The fundamental problem of cyclone, especially tropical cyclone, when it has circular motion, right? It's upward movement. After a point of time, it will be cooling, right? So it may not be able to reach up till the tropopause or where actual divergence takes place. So it may collapse. For every cyclone on the ground, there must be an anticyclone in the upper air. Remember that? Now, at a local level, since it is not globally supported by the entire atmospheric circulation, it has to generate its own ground condition and its own upper air condition. The air which is rising, let's say suppose in the case of equatorial region, the whole trade wind all the way coming from the tropical high pressure areas, subtropical high pressure areas, converging in the equatorial zone, so they're rising. So there is a system involved from the subtropical high pressure belt till the equatorial low pressure belt, and they are pushing, and a circulation is ultimately evolved. Right? What happens in the case of local conditions, and that too a regional local phenomena, smaller phenomena. So if the low pressure is developed, maybe because of high temperature, and that too when we are talking about the ocean surface, the temperature variation around will not be very strong, right? So the low pressure is developed, somehow it is rising. How it will be able to evolve that outflow, what we have talked about, divergence in the upper air. For that, it requires huge amount of energy in the top, which can re-energize the air to generate that height, to attain that height where outflow can be smooth. Getting that point? For that, it requires condensation, latent heat of condensation. Whenever latent heat of condensation is released, the air will be re-energized, right? For the latent heat of condensation to be released, air must form cloud. For the cloud formation, air must have huge amount of moisture. For the moisture supply, the surface must be ocean surface, right? And the temperature must be sufficient to supply enough amount of moisture to that. So the basic requirement of the tropical cyclone is not the temperature, but the moisture content in the air. Because it is this moisture content and latent heat of condensation which fuels the cyclone, which re-energizes the cyclone to generate the required outflow in the upper air. If it is rising, it must have an outflow in the upper air. So for it to develop, ground condition may be sufficient. When the air starts rising, it has to attain sufficient height to develop this outflow. So for this to take place, you need huge amount of energy in the middle of the atmosphere, and that will be supplied by latent heat of condensation. And a sequential order, the fundamental requirement of tropical cyclone is not temperature but moisture. Right? If it is about temperature, then this temperature will be available in the continental areas also. Why the dust devil dies out so quickly? Because it doesn't have moisture. It doesn't have the capacity to sustain that flow, right? So that's why it is required. That's why, and this high surface temperature, when we're talking about we are talking about the ocean surface. We're not talking about the land surface, right? Now, the possibility of the presence of such a high temperature over the ocean surface would be in and around tropical oceans water only. Hey, let's say if you go beyond 30-degree latitude or 25-degree latitude, the continent may present sometimes the temperature beyond that, but the ocean water will definitely not have. So because of this requirement, it is confined to tropical latitude. That means roughly around 25-degree north to 25-degree south. Second, moisture supply. Because of moisture supply, its location will be fixed. Location will be determined. Tropical cyclone, the location of tropical cyclone will be determined by high temperature and high moisture content in the air. This is a zone of trade wind, right? Now, zone of trade wind, if you look at here, in both the hemisphere, trade wind is onshore along the eastern coast of the continent, right? So, the moisture content in the air along the eastern coast will be very high and they will be relatively dry here, right? That's why the tropical ocean water, the location is fixed along the eastern coast of the ocean or the eastern coast of the continent, sorry, or the western coast of the ocean. Because, you can write down please in continuity, because the moisture content in the trade wind is maximum. Moisture content in the trade wind is maximum when it approaches the coast. Moisture content in the trade wind is maximum when it approaches to the coast. The ocean water bodies, the smaller ocean bodies are more favorable ground because of higher temperature. Smaller water bodies are more favorable ground because of higher temperature. For example, Caribbean Sea, where it is called hurricanes. Hurricanes. South China Sea, where it is called typhoons. Eastern coast of Australia, it's called Willy Willy. Willy Willy, W-I-L-L-Y, Willy Willy. Eastern coast of Australia, Willy Willy. Simply cyclones in Bay of Bengal, North Indian Ocean. Now here again you see the uniqueness of India. So that principle will be defied because both eastern coast and western coast receives onshore wind, right? So both coastal areas will be vulnerable for cyclones. There will be several reasons. We'll discuss that later. There are several reasons, but that will be defied here. Nowhere in the world, western coast of the continent breeds tropical cyclone. It may be experienced, but the breeding ground will not be accepted there, right? Sometimes, if the coastal areas or the continental areas are relatively smaller, the cyclones which are produced along the eastern coast may cross the western side also. Like the best example is the Panama Sumas. Very narrow land part. So when the cyclones which are produced in the Caribbean Sea, they can cross and go into the California side also. Right? That's again a rare phenomenon. Even if it is going, because they're crossing the land part where the moisture supply is blocked or stopped, they will not be that intense. Right? So wherever the chances are that the temperature is very high, the intensity of cyclone will be higher. The frequency of cyclone will be more, right? Now, the second requirement is the Coriolis force. Reasonably good amount of Coriolis force is required. Reasonably good amount of Coriolis force is required to give it a whirling characteristics or circular motion. Reasonably good amount of Coriolis force is required to give the cyclone a whirling character or circular direction of wind. Okay? Right? That's when we are talking about circular direction. Pressure gradient force will not give that circular shape. Right? So it will be associated with the presence of Coriolis force. Right? Now we can say that this is why, you can write down please, this is why the equatorial region does not experience tropical cyclone. Coriolis force is absent, zero. Equatorial region does not experience tropical cyclone. Hence, the latitudinal extent of tropical cyclone is generally confined to 7 degree to 25 degree latitude. 7 degree to 25 degree latitude, right? So 7 to 7 it will not be found. Closest ever recorded is in Philippines. Closest to equator ever recorded is it in Philippines. Third requirement is pre-existing low pressure system. Because of any reason, there will be regional variation in temperature of the ocean areas. And the area or the smaller region which has higher temperature will be a conducive ground for the formation of cyclone. Cyclones are the fourth stage of low pressure. So at least that area must have the to fulfill the criteria of first and second stage. So that other forces can come and intensify to make it depression, to make it vortices, and then it will be transformed into cyclone. Fourth requirement is the presence of anticyclonic condition in the upper air above the cyclone. For any reason, if that upper air circulation, just like we have taken example of the classroom, the atmospheric circulation, if you somehow choke that in the ceilings, if you block the divergence on the ceiling, the entire system will be blocked on the ground as well, right? So similarly, when the cyclones are formed, everything on the ground is perfectly available. Even when if somehow the divergence is blocked, that will definitely not allow the cyclone to produce. The best example is the southwest monsoon season, when the moisture content in the air is maximum, when the temperature is expected to be maximum, the cyclone frequency is least in India. Cyclones are more prevalent pre-monsoon period and post-monsoon period. One of the reasons is the presence of tropical easterly jet stream over Indian subcontinent. So easterly jet stream, it blocks its divergence, right? So that's why vortices are formed. And that's why vortices are the most important source of rainfall in the northern plain. That vortices would have been transformed into a tropical cyclone, right? The structure of a tropical cyclone. Generally, if you imagine it, three-dimensional figure will keep on increasing and spreading like this, where the wind is rising, just like a well. Circular motion, wind will not be able to reach and hit the center of the low pressure exactly. The way we have talked about the calm zone in the equatorial belt. Similarly, the central portion of that whole tropical cyclone will not be having wind, right? If you look at in two-dimensional figure, generally it will be like this. Air will be rising in this, slightly away from the central portion of the this is called wall of the cyclone. Both. This is also wall of the cyclone. Front wall, rear wall. This is called eye of the cyclone. Eye of the cyclone. That eye may be of sometimes 30-kilometer diameter. Generally, it may be less also. Now look at, if you understand the structure itself, you can understand the weather phenomena, you can understand any question in prelims or mains. What is the structure? Imagine a well. A well has circular shape structure, roughly similar you have a cyclonic structure, right? And all of us have experienced the weather phenomena associated with the cyclone. You must have experienced very intense, heavy rainfall for 1 or 2 days continuously, right? And thereafter, very clear sky, clean, neat, as if nothing has happened unless until you see the ground, right? Again, after 2 or 3 days, again you will have that. Means you are experiencing a vortex or a cyclone. Front fall will come, right? Will produce a lot of rainfall, cloud formation because rising air. The moment it has passed, eye is there. Now, eye is characterized by descending air, and the descending air does not produce clouds. So, calm condition, clear sky, no rainfall, no cloud, characteristics of eye. Once eye passed, rear wall. Again, similar condition.
I was wrong.
Just imagine a low pressure area here, right? And when the wind is coming from there, again, do you expect that it to come and hit here and then rise? Let's say, suppose this is a heater. The heater is of this much. This is the center of the heater, right? So when the air is coming from different direction, the Coriolis force will be applied. That's why high Coriolis force is required, right? So air is coming from all directions, right? So when the air is coming, Coriolis force will be stronger, right? So they'll start flowing in a circular direction without actually reaching up to the center of the air, right? So the center of the low pressure area or that heater will not experience hitting of air. Getting that? So that's why that will be circular in motion. ये देखा है डस्ट डेविल कभी नॉर्दर्न प्लेन कहाँ किस स्टेट से आते हो रोज देखते होगे गर्मी के दिन एक वो धूल उड़ती नहीं, धूल तो हमेशा उड़ती रहती है। हाँ, सर्कुलर वे में। क्या बोलते हैं उसको? यूपी में क्या बोलते हैं? बिहार में बिल्लुआ बोलते हैं उसको। कहाँ पे? राजस्थान में बतूलिया बोलते हैं। हाँ, लोकल। यूपी में कुछ बोलते हैं, हम फॉरगेटिंग। क्या यूपी वाले कुछ पता है? नहीं। तो मैं तो यूपी से वैसे भी कोई मतलब रहा नहीं होगा, नहीं? 5 साल तक थे। अच्छा। तो बेसिकली क्या होता है कि वो जो सर्कुलर मोशन होता है उसमें भी देखोगे ना, बहुत सारे लोग बचपन में कभी नहीं माँ बाप ने कहा है कि मत जाओ वहां पे, भाग जाओ, लेके चला जाएगा। और ये पता नहीं था कि पढ़ना पड़ेगा उसका, नहीं? तो याद कर ही लेते फिर हम लोग। So that dust devil is the exact replica of a tropical cyclone over the ocean surface, right? And very often you are told and warned that don't go into this; it will drag you. Yes. It is not possible in India, but very much possible in South China Sea and Caribbean Sea. And that very strong, very small circular cyclone with very high intensity of wind velocity is called tornado. And tornado has the capacity to keep the human up in the sky. Till date, no scientist has ever calculated the wind speed in a tornado. The rough estimation is that the wind speed is around 600 kilometers per hour. Recently, a lady scientist of NASA tried to enter into it and calculate the wind speed. And it's not a joke what you're going to hear it now. She was kept for almost 4 hours in the atmosphere. Was kept hanging for almost 4 hours in the center of the tornado, uh, in that. And then she fell. Obviously, NASA is perfectly capable of saving their precious scientist. So she didn't die, but she was for 4 hours. She was in the atmosphere. Even she couldn't calculate the speed of the wind. Right? So that's the general structure of the cyclone and the weather associated with it.